Okay, here we go. Yeah, hi, I'm Suman Vatrai, and my student ID is 2022035118. This is my assessment 3 video. I will cover why I replaced RIP with OSPF, my redundancy and wireless security recommendation, my monitoring choice, and then show the GRE VPN tunnel live in Packet Tracer. So in assessment 2 we actually used RIP version 2. RIP has 3 problems that cause delays. The client reported: 1. RIP only uses hop count. It has no idea how fast a link is, and so it could send traffic down a slow 64 kilobit serial link instead of a faster path. 2. RIP broadcast the full routing table every 30 seconds. So when anything changes, every router waits up to 30 seconds to find out. Uh, that's the delay. So 3. RIP maxes out at 15 hops, so it doesn't scale. I replace it with OSPF uses triggered updates. It only sends information when something changes, so convergence takes seconds, not minutes. It also uses a cost metric based on bandwidth, so it automatically prefers faster links. It is an open standard, so it works across all vendors. I also evaluated EIGRP, which has even faster sub-second convergence using dual algorithm. EIGRP is excellent in a Cisco only environment. I chose OSPF for its vendor neutrality. For redundancy, assessment 2 already has Ether channel with LSCP between the multi-layer switch and both access switches, which gives us link redundancy. I additionally recommend RSTP for loop prevention and HSRP for gateway redundancy if a second router is added. So for wireless security, let's talk about the wireless security. The main threats are rogue access points, deauthentication attacks, and password brute forcing. My solution is WPA3 Enterprise with 802.1x and radius authentication. This means no shared password. Every user authenticates individually. WPA3 also enables protected management frames, which blocks deauthentication attacks. Each SSID maps to an existing VLAN, and guests get a completely isolated VLAN with internet only access. For monitoring tool, I choose PRTG network monitor. It auto discovers all Cisco devices and also has built-in sensors for OSPF, VPN tunnels, and Ether channel. Repo also supports remote probes at Sydney, and cost around $2,500, and it's actually one-time lifetime access, so we can have lifetime access versus like example SolarWinds, which is over 15,000 per year, which is a very expensive. So let's quickly go through a demo. So now I'm here at the Packet Tracer, and you can see Melbourne office is on the right hand side, and then the Sydney office is left hand side, and you can see there is a multi-layer switch which connects to a router and also connects to switch. This is the switch 1 S1 Melbourne switch 1, which is connected to for the IT branch IT department, and then here you can see Melbourne switch 2, which is for the HR department. So let's quickly go through the Sydney router and do some few commands, and I'm just gonna show you. Let's do the interface tunnel. Yes, so on Sydney router, you can see tunnel 0 is up, you can see it here, and then line protocol is up. Tunnel source is serial 010 at 172.16.0.1. destination is Melbourne R at 172.16.0.2, and protocol is GRE over IP. Tunnel is active. You can see the tunnel is active. So let's see the another thing, which is OSPF neighbor. You can clearly see here OSPF neighbor table. You can see Melbourne router ID 2.2.2.2 appearing twice, once over the physical serial link, critically, and also once over the tunnel 0. Here you can see at 10.10.2. So state is full on both. This means OSPF is running through the GRE tunnel, and routing information has been fully exchanged between the two branches. So, and we can see one more thing actually I want to show, which is IP route for Sydney router. So if you can see here IT route for routing table on Sydney router, at the bottom you can see two OSPF routes marks 0.0 Mark 0, 192.18.0.0/21, you can see it here, and Melbourne IT VLAN and 192.18.8.0/21 is actually for Melbourne HR VLAN. Both launched via 10.10.10.2 through tunnel 0. Sydney knows how to reach both Melbourne VLANs through the tunnel. So we're gonna do the quickly ping test, and so I'm just speaking fast because I need is just to make sure the video is under 5 minutes. Anyway, so the ping, let's do the ping from Melbourne ITPC, where we're gonna ping from 10.18.1.2. so you can see now we can have the it's pinging Sydney server from Melbourne ITPC, 4 out of 4 replies, which means it's completely like working right now. And we're gonna go for same thing we're gonna do for Melbourne HRPC as well, where we're gonna ping 10.18.1.2, same thing, where you can see there is a reply from same test from Melbourne HRPC, 4 out of 4 successful. Both VLANs have full connectivity to Sydney through the tunnel. Now we're gonna go to Sydney router, and Sydney router here we're gonna ping again, ping 10.10.10.2. yeah, you can see now the success rate is 100%, and pinging the Melbourne tunnel endpoint from Sydney router, 5 out of 5. GRE tunnel confirmed working in both direction. So to summarize, RIP replaced with OSPF, fixing convergence delays. A GRE tunnel implemented between both routers with OSPF running over it. Wireless security designed around WPA3 Enterprise and 802.1x. PRTG selected for monitoring. Full details are in the written report. Thank you.